Hello again. In this video, we're going to be talking about still on the introduction of quantum computing, but looking at the second part, which is differences between classical and quantum computing. So that's the section that we're going to cover in this video. If you want to see the other sections, then subscribe to the channel, and you're going to get notifications when each one of those sections is recorded. Or you if your company or your organization has subscription to the digital library of O'Reilly, then you can subscribe to the course. Most big companies have this subscription. People just don't know. Actually, every university has a subscription to the O'Reilly library. And where is it gone now? Okay, here, there we are. So that's gonna happen on 2nd of September. You can watch it then. There's other courses that would happen at different stages. So this one would happen on the 15th of September, and that's on the AI attack surface. So I'm going to be talking about the top 10 most critical threats to AI and cybersecurity. And there's another course. This one is on the 10th of October, British summertime, between 6 p.m. and 10 p.m. Central European time. This is on the agentic AI and cybersecurity risks. So those are all the different courses that you can subscribe with Pearson's and O'Reilly if your organization has a subscription. And again, every university in the US and Europe has a subscription usually, and most big companies have. People don't know. But if you prefer to watch things on YouTube, this is my preparation for the course, and everything is going to be completely free. I'm not going to ask for any money for my preparation. This is all in the interest of having things openly available in public access. Actually, my YouTube channels are not monetized, so even if you think that I'm getting paid, I don't. YouTube, it's completely free thing. It's a hobby for me. It's not something that I get money from. I actually get a job. So if you want to know more about me, my day job is this. I work for the University of Oxford Department of Computer Science, and here you're going to find loads of things about my profile. So you can find my Scopus, Web of Science. I also work for the Turing Institute, so this is my profile with the Turing Institute. The Turing Institute is number one in the UK for artificial intelligence, and it's quite okay in the world. I don't know what the actual ranking is. So anyways, in this session, we're going to be talking about the differences between quantum and classical computing. And let me show you what I have prepared. So I have this section 1.2, and if I open, I will try to open all 12. Okay, so there we are, all 12 open. This is a good trick to know about Google Chrome, how you can open 12 windows at once. Starting from the first article that I have, and these are basically all pre-selected articles that I have carefully chosen because they are reliable and they're of good sources, and they're leading in the world, and they're most quoted, the most cited, the most popular. So that's why I have chosen those. So quantum computing in the NISQ era. You would think it sounds like NIST, but it's not. It's this noisy intermediate scale quantum technology. So this is one of the most read papers, and that's why I'm including it here. It has quite a lot of attraction, and so you can open the paper by clicking on the link here. You can get the full text if you click on that button. It's open access, as you can see. This is from 2018 though, so be careful because things change. So this is one of the interesting papers that is explaining the differences between quantum computers and classical computers. But I'm not going to read that because just it's going to be very long and tedious. Just wanted to show you what you could read if you have free time, if you wanted to get additional information. So here we have another very popular article on the physical implementation of quantum computation. So, and with this one, you can get it. You can click the PDF over there. And for this one, as you can see, it's not in open access because if I connect there, if I click that, in my university would provide the subscription for me so I can read it. But if you want to get the full access, you have to pay £48, which is not ideal, that is why let's try if we can find this as a preprint. And this is the trick that we're doing now. And boom, here is how you save £48. So there's a physical implementation of quantum computing, the same author from IBM, and you can open this article and read it in, completely for free. This is the article. Now, if we go back a few steps, here you see it's asking £42 and just showing you the tricks of how you can get most of the information for free. You can see that the article is the title and the author is here. So that is the same title and this is the same author. And in the previous video, I explained why this is happening. This is not the author that is tries to make a lot of money. I showed you with demonstration with Google Scholar, no, Google Scholar. Hold on, just give me 1 second. I want to demonstrate this. So you see, all of those articles are free. When you click on the link up there, it would open the article. So I'm just going to pick this one, I'm going to open, and now it should open the article and you would be able to read it, because my university has a subscription that they actually pay £3,000 or as much as they need to pay. You can see the article is open, you can read it here. And if you want to download it, you can download the article, download as a PDF. You can download it in various different formats. Why is this article charging you £42? Because the university or the employer of this author, David Vindanzo, probably didn't have a subscription with that specific journal. So it's not that the author is going to make that money. That's not money that the author. So here we are. This has been downloaded, and as you can see, that article is completely downloaded, and you can, there's loads of articles that you can do. All of my articles are like that. But in this case, the author university didn't have subscription. You don't have to pay. There you are. I showed you a quick trick how you can get that paper for free. So this person works for IBM, and this is a very long and technical paper. As you can see from the slides over here, there's nothing really, there's no figures, there's no diagrams, there's nothing, but it's one of the most popular papers in the world. Many people actually do spend money to buy subscription just to read it, and you don't have to do that. It doesn't mean, I'm not saying don't buy subscription but if you don't have the money, you can still read it. Like, it's the same paper. This is a preprint. The only difference is it does not have the formatting of the journal, but this version is the one that was accepted by the journal after peer review, after editorial review, everything. So just the graphics of the logo is not there. So there you go. You know how to get it for free. If you want to read the paper, this would be a very valid paper. It's from November 2024, which means it's fairly recent. It's from IBM, and it's one of the leading papers in the world that everybody is reading. So this is a second one. For this paper, I'm already showing you the preprint. I didn't take you through the journal just because it's just going to be, it's going to get very long, and you know how to do that already. So this is a preprint here, and you can read this other paper as well. This is another leading paper in quantum computing. Most of the quantum computing papers are not that easy to digest. That is why I'm recording this video, when I'm actually going to show you how those things operate without the sigmas and the gammas. But if you want to read it, you don't have to pay for this either. It's publicly available, and you just type that name in Google, preprint will open it up for you, or archive or somewhere. This is another one, another very interesting paper. Again, the same trick applies. This is a preprint version of the original paper. If you were paying money now, and if you paid £45 subscription for each one of those, you're already minus £120 per month subscription, just only for 3 different. So here you know how to get these papers for free. Actually, education shouldn't really cost that much, but as you can see, this is another very highly technical paper. Good luck to you figuring what that is. You need to be a mathematician, and if you're a mathematician, these things, they make sense to you. So you see them and everything is very clear. For example, PhD in mathematics, it's very short comparing to PhD in humanities. PhD in engineering, which my PhD is in engineering, it's also very short, 40,000 words, as opposed to humanities, which is 80,000 words, sometimes 120,000 words, depending on the university. So because we use these formulas, that's why it's shorter. So in this one formula, it's everything is clear, but you need to know how to read it. If you don't know how to read it, it's not for you. Um, this is another interesting paper, decoherence and quantum origins of the classical. So now let's see if we can open this paper. Um, Hopefully this is going to work, since I have listed it like this. Probably I have checked it, and this should open. Oh no, you have to log in with the institution. So I guess this was another example that I was using just to show you how you could get it. Let's see, block vectors for credits. Okay, so hold on, let me go back. So this is an interesting paper, but you need to do the trick that you look for the preprint. Otherwise, it's going to ask you for a subscription. But this is another one of the top 10 or top 20 papers on quantum computing. So this is block vectors. It's an archive. As you can see here, that's the original paper. So if you click on that one, you would be able to open the block vectors. And actually, I have it open here. So this is the block vectors if you want to have the original paper, but as you can see, you have to pay the subscription, but on archive, you can see it for free. So we're just going to open this for free, and this is it. If you want to read it, it's another paper, very technical, very cryptographers are a different breed. So this is another paper of how that you can read. Let me close that. That's closed. Here we have one of the theory of quantum information. This is from the University of Waterloo. This is, if you're doing a course in the university, this should be, it's always going to be, unless your teacher is not very good, this is going to be one of the compulsory readings. It's published by the Cambridge University Press. It's going to be this. I have the open access full version of this document, which is called, let me see how many pages this is going to be. Oh, I can't. This is a very, very, very long document. So let me scroll all the way to the end. This is going to be 500, and this is 590 pages. 590 pages of pure formulas. So let's just look at one page. You have 590 pages of this. And quite often I say that nobody really understands quantum mechanics and quantum computing, and people just take it with a, like, oh, but it's not true. 590 pages, of this. So, you need a long time to understand it. And this is just one of the compulsory readings. It's going to be, I showed you a lot more readings. So I can't even scroll quickly enough. But if you wanted to read something, and if you're determined to know the very technical aspects of quantum mechanics, the Theory of Quantum Information by John Walters from the University of Waterloo, this is one of the key readings in this topic. Okay, so what did I do? Okay, close that. Another very interesting read, which is, again, you have to get the ebook if you want to read the Quantum Computing Progress and Prospects from 2019. You can read the full description here. Before you engage into buying this kind of technical books that they are full of formulas, just ask yourself, are you going to be able to understand it, or is it just going to sit there and collect dust on your shelf? Because I can tell you that I struggle to understand this book, and I work in cybersecurity for 20 years. But I don't work in quantum, you see, that's the difference. Quantum is physics. So this is another of those Bibles that you need to read. I strongly suggest that you go to a library and you open it first before you buy it. So that's and here we have a standard for quantum technology definitions. This is from IEEE standard associations, and this is the working groups on standards development. So this is a standard on quantum technologies, and how do we define them? Probably you should start from familiarizing with the standards before you actually read technical books on quantum mechanics. But I did list all the books that they are compulsory readings in case you are determined to buy them, and then somebody would light the fire once you're dead, because you're not going to read them. If you don't have a degree in that subject, you won't be able to understand it. So anyways, we have another standard here from ITU. You have the PDF over there that you can download. The standards are usually for free. You just read the standard. And this is just an overview of the network supporting quantum key distribution. So I'm glad this. So the first video that I recorded was long. The second video that I recorded on the basics on quantum mechanics was very long as well, and that's why I'm trying to reduce my time, because when I present this course or with Pearsons and O'Reilly, those people I have only 15 minutes to cover all of these topics. So why am I clicking that? 15 minutes to cover all of those topics. You see how many topics? And it's not easy to cover so many topics in 15 minutes. So that's why I'm preparing here. But I did manage to cover this topic much quicker than what I did with that one yesterday. So let's look at the next one, overview of AI, or maybe not. Maybe I'll stop the video here, record the second video like that, and put it in a playlist, because if it's too long, people just won't watch it. Again, if you have subscription, if your university, if your organization has subscription in Pearson and O'Reilly, just go there, type my name in the search engine here, and you will find loads of the courses that I'm doing, depending on when you watch this video. If you watch at a future date, then clearly there's going to be a completely different set of courses. And many people have full access to this, and they don't really realize that they have free subscription to these courses. So they pay hundreds of thousands of pounds to go to university, and most of the university senior academics, they actually teach with Pearsons and O'Reilly. And if you have free subscription, why not watch that for free? But in case you don't, and subscribe to the YouTube channel, and you're gonna keep getting these notifications. You're gonna get the videos in more less refined format. So if you sign up and if you watch that, on 2nd of September, that's going to be very polished, very quick, very professional. I'm going to shave. But if you watch the YouTube video, it's just me in my room doing the recordings for people who don't have subscription with Pearson O'Reilly to watch it, and also to make it as an advertisement, because some people do have Pearson's and O'Reilly subscription, but they don't realize, and then they go to their digital library subscription, and they realize that they have this subscription, and then opens up a whole new world for them. See you in the next one.